Hi, everybody. Welcome to my talk about machine learning in 25 minutes. I'm very honored and happy to be part of this amazing event, and I'm glad you are all joining here. So, my name is Helskyaho, and as you already figured out, the last name is impossible to pronounce, so people usually know me by Heli from Finland. And the reason for that is that I do come from Finland. I have graduated from University of Helsinki with master's degree in computer science, and I'm currently working on my doctoral studies. And those are actually related to machine learning, and that's why I really love to talk about machine learning. I've been working with Oracle products for very, very long, but with my machine learning studies, I have actually been investigating much broader area than just Oracle products, which, by the way, are still great and amazing. Anything to do with data and databases is very close to my heart, which also brings to machine learning because machine learning is a lot mostly about data. I'm a CEO for Merkle Finland, a small consulting company in Finland. Oracle ACE Director and Oracle Groundbreaker Ambassador. These are some kind of award programs in Oracle where they recognize people who know a lot, are willing to share what they know, and are even able to share the knowledge. I have listed as one of the top 100 IT influencers in Finland 4 years, 5 years a row. I speak a lot, which is not very common for Finns. We are known to be quiet people, but I enjoy speaking. But being very honest, webinars are not my thing. I'm very scared of this, so I'm always nervous when I'm presenting in a webinar. It's much easier when I see your faces. So let's hope this will go well anyway. I also write books. So I have written 2 books about database designing and about SQL and PL SQL, and currently working on a book about, surprise, surprise, machine learning. So, what is this machine learning? It's an important part of artificial intelligence. Machine learning teaches computers to learn from their experience, which is the algorithms. So, you learn from data and you make predictions based on the data. It's about mathematics, it's about statistics, about a lot of different things, but it's also about understanding your business. It's not just a computational task. It's a field of study that gives computers the ability to learn without being explicitly programmed, said Mr. Arthur Samuel in 1959. So there's many ways of describing what machine learning is all about. You could also say that it's a systematic study of algorithms and systems that improve either their knowledge or their performance with experience. We have a thing called big data, which has brought a lot of challenges for us to manage our data. We have more and more data, the volume. We have different data models and formats, the variety. We have loading in progress while we are already doing data exploration, which is the velocity. And not all the data we have now is actually reliable, which is the veracity. And we don't know what we're actually looking for. So we have value, viability, variability. And we must support non-technical users like journalists, investors, politicians with visualization. And all this must be done efficiently and fast. So it must be done by computers. We can't do it manually. So this might bring us to machine learning. Could that be a solution for all these problems? So why do we talk about machine learning now? It was 1959 when we had the definition, and now everybody's talking about machine learning. Well, we're not just only forced to use machine learning because of the big data and the amount of data, the different data, and so on. But it's also that we are now possible to use. We are finally able to use machine learning because of the improved technology. We have the GPUs, TPUs, and a lot of improved technology that makes it possible. And the storage price has gone down, so we are able to really store the data that we have available. By the way, it's growing all the time, so we need more and more storage. We have existing data sets that we can actually use for our machine learning, and we have pre-trained models, and we have research. So all the scientific research is actually bringing a lot to this field. I just put FB here to remember to mention you that we always talk a lot of bad about Facebook, but Facebook is doing a lot of good for machine learning because they are actually, when they do research on machine learning, they share the knowledge with us. So it's not a company secret. They really share with the audience. So what kind of research they do is available for us all. So I think that is a great thing, whatever you think about the company itself. Other ways. So in short, we are living in an environment that needs machine learning and we are also finally able to really use it. So when can I use machine learning? Like anything else, machine learning is not a silver bullet. So it's not that if you have a problem with data, the solution is machine learning. No. So, but it starts with the data. You need to have data because if you don't have data, machine learning is no use. It requires data. Machine learning might be useful when the rules and equations are complex, like in image recognition, or they're constantly changing, like in fraud detection. So if it's a program that you cannot program with if, else, then, or something more complex. So the nature of the data changes and the program must adapt to that. Real-life use cases for machine learning might be spam filters or data analytics, robotics, and medical diagnosis, which is something that I find very exciting because with machine learning, we can do things that we are not able to do without machine learning, like analyzing photos of cancer or some kind of sickness in a place where you don't have doctors. You can take a picture with a phone, and with that picture, the computer, the machine learning that is in your phone can actually analyze it and give you results just like that. And also, for something that is very difficult for human eyes to see, the computers can see it very easily. So I think any kind of medical side will be very interesting and is very interesting for machine learning. So machine learning is about unsupervised learning, supervised learning, or reinforcement learning. Unsupervised learning finds hidden patterns or intrinsic structures in input data. So we have a data that we don't know what it is, and we are trying to find something, some kind of information, useful knowledge from that data. Usually what we use is clustering or anomaly detection. Anomaly detection can also be used with supervised or semi-supervised machine learning. I don't talk about semi-supervised in this one because it's a narrow area. Supervised learning trains a model on known input and known output data to predict the future outputs. What we usually use there is classification and regression. I talk more about this a bit later. And then we have reinforcement learning. That is actually when the machine or software learns by itself without, without any data we give it because it's generating its own data. It gets feedback from the environment and learns and builds its own data based on that. So unsupervised learning. So it is learning from unlabeled input data, and we don't know the target. So we don't know what we are trying to predict. So we just have a lot of data and we want to find some kind of hidden patterns from that. Unsupervised learning is typically used when we don't have a specific goal, or the target variable is unknown, or we are not sure what information the data contains. And one use case also for unsupervised machine learning is to reduce the features of your data as pre-processing for supervised learning. It's called dimensionality reduction. So we kind of pre-process the data so it's readier for supervised learning. I mentioned clustering earlier. So the most typical um, algorithm would be some kind of clustering algorithm. For the clustering, I need to tell things called hyperparameters, which are parameters I tell before the learning starts. In this example, I would have told I will have 3 different clusters. So the hyperparameter would be number of clusters 3. So the computer walks through all my data entries here and puts them in 3 clusters to find me customers who like dogs, cats, and horses. So different categories of customers. Another thing is anomaly detection. So that is to find anomalies, exceptions from the data. As I mentioned, this can be also with supervised or semi-supervised, but typically it's with unsupervised. So we try to find some kind of exceptions from the data. Of course, it's very hard to know when is it exception, and it's harder to decide if it's an exception or if it's normal. But that is a good technique for, let's say, locks or alarms to know that if something is going on. If a lot of attempts to enter your system without knowing credentials might be an anomaly. You see that somebody's trying to hack. So supervised learning, we are learning from known labeled data. So we know what the data is about. And we know what is our target. What are we trying to do with the data? We are trying to find those customers who are about to leave our company. So we need to do something to keep them as customers. So we train a model on known input and known output data. And then we actually test it also with known input and known output to know how well it actually survives, how well it predicts. Then we compare the prediction to the known output to know how well it did. So here the key is that we know both input and output to know if it's learning. So first we learn, first we teach with known input and output, and then we test with known input and output. So usually this means that we have a data set that we split in two parts, sometimes even three. So we split it in two parts for training and for testing. I mentioned earlier that classification is one of the things we do when we do supervised learning. Classification, there's two ways of doing classification. Binary classification, when we just have two classes where we put all our elements. We have cats or we have dogs. Or we have multi-class classification where we have the cats and the dogs and the horses. So classification is all about putting things into categories. This customer, we should give him a credit card. And this customer, we should definitely not give a credit card because this customer is not worth it. We will never get our money if we give a credit card. So classification is one of the classical examples of machine learning. Regression is about predicting numbers. So we are trying to predict, based on our experience with the data, what is the stock price for Nokia stock next Monday, or what is the temperature tomorrow, and so on. So we are trying to figure out what is the number when we know these features. So that's regression. Classification is about putting things into classes, while as regression is actually finding a number. Everybody is talking about deep learning nowadays. So deep learning is supervised learning, but in the upper corner here, you can see input, feature extraction, classification, and then if it's a car or if it's not a car. So we are classifying two classes, cars or not classes. So this is supervised learning. But if we do it with deep learning, we don't have to do this feature extraction part, which actually means that we need to understand the features much, much better to be able to do it. Now we let the computer to do it for us. So it's the same thing, but of course it's heavier. It needs a lot of computation power, and it actually needs a lot of time. So instead of doing the work yourself, you let the computer do it. So how does this deep learning work? It's used for computer vision, face recognition, and so on, speech recognition, text processing, and so on and so on. But it needs a lot of data and resources. It's been improved a bit with pre-built data sets, pre-built and pre-trained models, and transfer learning, which means that already one model learned something and we are transferring that learning to another one. But it's still a lot of work. One of the improvements, a crucial improvement for deep learning, was invention, or actually figuring out that convolutional neural networks would be a solution for deep learning. So instead of just having the neural networks that you can see on the right-hand side, we also have convolutional layers on top of it. We could have 50, 100, or whatever number of convolutional layers, which consist of filters, output, and pooling layers. And all this will be flattened for neural networks to process. This is actually quite new, well, new depending who you talk to, but for me, because 1995 or 6, anything to do with neural networks was a joke. If you submitted a paper on neural networks to a scientific event or scientific paper, it was rejected because neural networks were a joke. Until convolutional neural networks were joined to that and proven with all the pre-trained data sets, pre-trained models and data sets, that actually this is working pretty well. So this kind of saved the idea, and now it's very, very popular. How actually this network learns is with backpropagation or backward propagation. I don't go to details on this because I only have the 25 minutes, but it goes on predicting, then comparing the prediction with the true target, finding the loss function, which tells how lost actually are we with our prediction. Then, depending what kind of optimizer we use, we go and update the weights and so on and so on. So backpropagation is the way that it's learning. Use cases for deep learning would be text or voice, any kind of processing for that, natural language processing, text to speed, whatever. There's a concern about this, like everything else, there's always a concern. People are concerned that in the future, there's no need to learn to read anymore because computers will do a resume of the text for you. It will read you aloud the text and so on. So you don't have to know anymore how to read, and you don't know how to write either, because you can just speak and the computer will type it for you. I tried to type my abstract for this presentation using Talk to Transformer. On the lower right corner, you can see the link for this one. It's actually quite a nonsense abstract if I read it carefully. So probably I will not use this for my future abstracts. Then I used another one, which also makes quite a nonsense abstract for me, but this is very fun to play with if you want to try how text is processed. I also tried translating. I wrote here in Finnish that I'm going to give a presentation about deep learning in Apex Connect event, which I did last week, but it didn't know deep learning word. It says in-depth learning. So translation didn't really work so well. Another use case for deep learning would be recommender systems. So any kind of recommendations for users to make their decisions easier. There are collaborative filters which are using other users' similar taste to know what you would be liking. Then there are also content-based recommendation systems that use the similarities of new items, that you already like an item and there's a new item that is quite similar to that one, so probably you will like it as well. And then hybrids of those. I tested Amazon. Amazon knows actually nothing about me because when I order books, my son orders with using his account. The only time I probably used Amazon was in Tokyo when I was ordering some shampoo and conditioner. And here you see what I get. I really don't do knitting and I don't know Japanese language and many of the languages here either. So none of these books would be something that I would really buy. Then I tried with Netflix. Netflix knows about me and it says, because you watch Another Life, you probably would like to watch these as well. I have actually seen most of these, but it doesn't know I have seen them. So quite interesting as well. It had already forgotten that I have seen them. One very important and interesting thing is any kind of visual recognitions, like image classification, object recognition, object detection, image captioning, action captioning, like somebody's cycling or somebody's running or somebody's whatever doing something, or object image segmentations when you are separating the objects from the background. Just like here, where you can see there are traffic lights, persons, cars, truck, and so on and so on. So all this is done by deep learning. So what if we don't have data available? The computer creates its own data. So this is an example when the car is driving in a parking lot and trying to learn how to park. It didn't start very well because the computer doesn't know you are not allowed to hit anything. So it takes a while to learn that. After 10,000 attempts, it's already kind of figuring out where it is. After 20,000 tries, it's already finding the parking slot here. But after 30,000 attempts, it's hitting a car, so it still didn't learn. Almost in 50,000 times, it's knowing where to park. 100,000, we already found the place we might be able to park. 310,000 attempts later, it's starting to be confident and not hitting the other cars or lights or anything in the area. So the computer doesn't pre-know things that we know in our lives. So as a child, you already learned that you are not allowed to hit anything. So you kind of pre-learn things the computer doesn't know. So the way the computer learned here was using reinforcement learning. So the agent, which was the car, is in an environment, which was the parking lot. It does a movement, moves from one state to another in the environment, and gets a reward. You did well or you did badly. And based on these rewards, it's learning what actions to take and what actions not to take. The problem with the reward is that it might be very late. So this you could compare it to training your dog. So if your dog learns something and 1 hour later you give the treat to your dog, how would the dog know what was right and what was wrong? It will always attach it to the latest action. And so is reinforcement learning. So we should have rewards um, soon enough after the action was taken, but still it's not easy to do it like that. It's very good with games like AlphaGo and AlphaGo Zero, but is it good with everything else? Because it really needs a lot of try and errors. What about this car? If we just let the car park by itself on a parking lot, a real parking lot, 300,000 times and crashing all the cars, maybe we don't want to do that. What we really want from artificial intelligence is a machine that can learn and maybe even think like a human. Deep learning with reasoning, the common sense, ability to learn background information without attaching it to any particular task, being curious observation, learning that green is a green color, it's not just a grass that is green. Maybe self-supervised learning might be the next step. Predicting the future from past, predicting the future from recent past, predicting past from present, predicting anything from everything will actually make it possible to train the data uh, in autonomously. So autonomously labeling the training data would be self-supervised learning, which is quite an interesting area. Or maybe it could be self-supervised reinforcement learning that we will see in the future. Um, Whatever you do, just know that the future is here. Artificial intelligence and machine learning is here, and they will stay. And there are so many interesting areas to learn in that area. So just pick your area and start learning because this is definitely useful information for you today and also in the future because this is the future. Thank you so much for attending and thank you for letting me speak. Thank you.